Right, so fun man. So we're here today on the light bulb, right?
Yeah, again, I'm so happy.
Right, and today I want to talk about nucleation sites.
Nucleation sites?
Yeah, so when something boils or something freezes, right? Actually they boil and freeze. The boiling and freezing starts at some point.
Okay, tell me more.
Right, so let's say in the lab practical, right? So let's say we have a conical flask over here. Right? So and you have some liquid inside.
So much. Anyway, yeah.
Right, so you have some liquid inside, right?
Yeah.
And so, let's say, we boil the liquid.
Yeah, boil the liquid. Yeah, okay.
Right. But, when we boil something, usually a lot of times we add this thing called boiling chips inside, right?
Yeah, we add boiling chips for a reason, right?
Yeah. Right, so the boiling chips act as nucleation sites, right? And I think it's very clear on, if you look at what would happen if you don't have a boiling chip inside.
Yes. So just imagine, right, when you have a big beaker here. I also put the same amount of water as you, okay? That's too much, okay? But you see that without the boiling chips, right, what I encounter, and this is also at home here when we boil soup, right, the nice soup,
Yeah.
that things will just bubble because the liquid gets superheated, right, overheated, and it bubbles, and it just rocked the whole container.
Yeah.
Yeah.
Right, and I think we know this as bumping.
Bumping, that's the effect here, Opa. And by adding boiling chips, right, we are
preventing this because, we add many tiny, small sites, right, for the bubbles to form.
Yes, so let's come back to here. Why bumping occurs is, right, you see the base of this conical flask here is in direct contact with the heat source, right?
Yep.
So which means that, right, the liquids here residing at the bottom here gets more kinetic energy than those at the top here, right? And they're trying to become a gaseous state because once they reach the temperature, for them to transit between a liquid state
to a
gas, right? Which means that at some point here, they become gases.
Yep.
And the gas could be very small, but there's so many molecules inside. And they join and become
very, very big bubbles,
very big, right? But a question for you, Opa, why do they become big bubbles and then they rise? Or why do they become big bubbles? Why are they not just small bubbles?
Well, I mean, that's a good question, right? So from what I learned, right, it's got to do with superheating, right? So, at this point, right, there's a lot of small place for the bubbles to form.
Yeah.
Right, so the moment it hit the boiling point, then, bubble already.
Yes.
Right, but here, when it hits boiling point, there's nothing for the bubble to form, right? There are no nucleation sites.
Yes, so one key idea is, right, for bubbles to form, you need a surface. Normally, you need a good solid surface here, then you form a bubble here. Imagine, right, in your childhood, in the bathroom here, we play with soap, right? We form bubbles, right?
Yeah.
It's the same reason here when you put the soap, let's say on the hand, right? And then we combine and it becomes bigger bubble. And it's all about surface tension. So the small ones, I think I was referring to, that the small bubbles came out and then they combine and forms big bubble here. But there is a point when the big bubble is not sustainable and then it will just rise here. And when there are lots of these bubbles here, it just keeps on rocking the conical flask.
Yeah.
So that's why we are talking about nucleation site.
Right.
About boiling chips.
Right, and I think there's another, then we can see at the other side of the spectrum as well, right? So instead of boiling, we can talk about freezing.
Freezing, okay, tell us more.
So, so there's this, there used to be this phenomenon, like the internet thing, right?
What's that?
Where you super cool water, and you smash it against your head and it becomes ice instantly.
Wow.
Right?
Yeah.
So yeah, I mean, so if you want to try this at home, you can use something like Fiji water, put in your freezer. Yeah, Fiji water, right? It's very important that it's Fiji water.
Must be Fiji water, okay? Is it from the country, Fiji, or just the brand?
It's the brand Fiji.
It's the brand. We are not selling the brand, but I must agree that brand tastes pretty well.
Okay.
Okay, why Fiji water?
So, what I heard is that, Fiji water is much more pure than any other bottled water out there, right? Even, things like tap water.
Wow, purity, okay. Which means it contains minimum ions, minimum other minerals or gases. Okay.
Right, and so, we come back to nucleation sites, right? Because there are less other things than H2O, right? It's, then there's not many places for ice to start forming.
Yeah.
Right, and when ice starts forming, then it starts acting as a nucleation site, and other ice joins on top, and then, it grows in size.
Okay. So let's wrap this up. Well, that adding boiling chips, right, creates many nucleation sites, right? So they form small bubbles here, right, or at the base. Then once it forms, it escapes.
Yep.
And then, therefore, when you have small bubbles, it doesn't rock the whole conical flask. So that's the reason why we add boiling chips.
Yep.
When we heat liquid, right?
Mm-hmm.
So see you next time.
See you next time.